pattern matching systems are very powerful, but dumb. And let's take a look at some common pattern matchers that we hear about all the time. We hear k-means, we hear vector databases, and of course, the most famous is AI coding tools. But here's where the magic comes in, is they all do essentially the same thing. They find patterns in numbers without understanding what those patterns mean. So in multidimensional space, like in the case of k-means clustering, you have an X, you have a Y, you have a Z, you have an age, you have a height, you have a weight. You could plot those together in a cluster, and you could see that, oh, look, we have the high school football players, we have the elementary school soccer players, we have a retirement league softball team, right? But still, once you plot these in multidimensional space, an expert has to go over to those groups and label what is actually in there. So similarly, like a search engine that finds books with similar words, it doesn't read them, it just finds the pattern. So these are the three cousins of pattern matching, and I think it's a way to demystify the coding assistant to get into the math of k-means and vector databases, because the math is very simple. It's almost elementary school math. If we take a look at k-means clustering, it's going to sort things into groups based on how similar they look. If we look at vector databases, you're going to find things that are most similar to what you're looking for. So in the case of vector databases, it's really just a series of items in a vector space where you have one component that's similar to another component, and potentially what's missing, you recommend it. In the case of coding assistant, you would suggest code that statistically matches a similar situation. But the key insight here is that all three are just measuring the distance between points in space. So how could they possibly be intelligent? If we take a look at the human expert requirement here, we ultimately get down to the labeling problems. Computers can find patterns, but they can't name them. So in the case of k-means clustering, this might have a group of students by height and weight, but it couldn't identify that these are athletes. The domain expert has to come in and do that. Just like a vector database, it can find similar pictures, but it can't explain why they're similar. In the case of, the simple truth, a pattern is just a way to discover insights, but it's just math, right? It's not intelligence. So this is the validation gap, is that coding assistants suggest what looks like it could be right, but that's not actually a complete understanding. And that's not necessarily going to give you something that works. And so they can predict words based on patterns, not understanding. So the real world example is like a student who memorized all the answers on an exam, but then they actually don't know the subject. They just memorized what they were supposed to say. And this is the also the automation paradox. If the systems like these coding assistants are so smart, how could you not hire humans, right? So in the case of a company that's building these tools, if your tool is going to supposedly automate developers in a year, why are you hiring developers? It doesn't make sense. Or in the case of k-means clustering, if these things are so smart, why wouldn't the labels be automatically labeled? Or, how do we know that the k-means clustering tools shouldn't automatically pick the correct number of clusters? Now, you can use things like an elbow plot and all kinds of like mathematical terms to figure out the appropriate number of clusters, but there's no guarantee that the cluster you picked is correct or the label you picked is correct, because a human has to verify that it works. Likewise, in the real world of software engineering, if you take a look at things like infrastructure as code or Amazon CDK, if you ask it to generate some code, underneath the hood, it may generate something that's pretty close, but you're going to have to validate it and make it work. And is because ultimately this is pattern matching, not an understanding. So the core insight is that true intelligence understands the context. It understands the thing you're building, not just being able to recognize a pattern. And so this is really like a partnership, is that the machines, what they're good at is finding patterns very fast across huge amounts of data. So I think that's a better way to think about these emerging systems, is that instead of saying that they replace a human, they're just a very different tool. In the case of finding patterns across huge amounts of data, I mean, yes, that's very useful to be able to create a cluster across 10 million items, and you cluster to 3 clusters, and you say everything belongs to one of these 3 clusters. That would be amazing, right? And that's a human would take maybe years to do something similar. Likewise, human is going to do something very different, which is a human would provide the meaning, the context, the validation, and then in terms of the future direction, the better tools are going to help humans interpret the patterns, not replace humans. So really, if we get down to wrapping things up here, when a computer is sorting things by similarity, it's like organizing toys by a color, but not knowing what the toys are. So in the case of a computer taking red toys that are fire trucks and blue toys that are police cars, it just says, oh, look, we have a red group and we have a blue group. But a person might need to come along and say, hey, wait a second, I understand that you categorize these by red and blue, but in the case of this particular group, this is an emergency group, right? These are emergency vehicles. And so the human has to come in and differentiate between those two things. So the humans are good at patterns, and the people are good at explaining why those patterns matter the most. And I think this is really what we're going to see, is that the combination of using these kinds of tools as dumb but very powerful pattern matching systems, but also going deep into the math and understanding that the math, by the way, is not that difficult. You can write k-means clustering yourself in an hour in Python or R or Julia. It's that once you understand it's just pattern matching in multi-dimensional space, then this like idea that there's AGI, there's some kind of intelligence, goes away, because it's not that hard to understand at the core that these are just pattern matching systems.